This question gives us a function of x, and it says that we've got a quartic, a power of 4, divided by a quadratic, a power of 2. Using algebraic division, show that f of x can be simplified as this. So we're asked to basically perform this division where a, b, c are integers to be found. So let's just do that the way you may have learned algebraic long division. So what we've got is we've got x to the power of 4, add x cubed, take away 5x squared. Now it's very important here, there is no x term. Very important, there's no x term, but you need to write add 0x. You must do that, otherwise your columns are going to get all messed up. Take away 9. Now it's really important you spot that, because otherwise I promise you it will go all messy and you won't be doing it properly. So, and then on this one we're going to divide it by x squared, add x, take away 6. So what term must go up here to give me the x4 I want? Well, in the x squared term, if I put an x squared, I get x to the power of 4 plus x to the power of 3, take away 6x squared. And I can subtract all these. So I can put a line underneath and I could subtract them, and I would just leave myself with an x squared. So what must go up here to give me the x squared? Well, clearly 1 does. So I put a 1 in the 1 column, and that gives me, I would bring these down as well, plus 0x, take away 9, and putting in 1 there, I get x squared, add an x, and I get take away 6. Now if you hadn't put in the 0x, you would have mucked it all up here, so you could put a line underneath at this point, take them away from each other, and I'd get myself negative x, and negative 6, take away negative 9, take away negative 6, is just going to be negative 3. Okay, so therefore writing this in the right form, f of x is therefore equal to this term here, which is x squared add 1, and this remainder divided by that there. So it's going to be a plus negative x subtract 3, all divided by x squared add x, take away 6. If you look up in your question, have we got there? Well, actually no, there's only a linear, an x on the bottom, not an x squared. So you should be looking at that and thinking, well, either I've made a mistake or maybe I could do something further. And you can. What you can do is you can do a factorization. You can factorize a negative 1 out of the top, and the bottom can be factorized to x add 3, x take away 2. And in that case, you can divide the top and bottom by the common factor of x add 3, and your f of x suddenly simplifies into x squared add 1, and then it's going to be take away 1 over x take away 2, like that. And you might actually write your takeaway here. So then in the question, our a is 1, our b is negative 1, and our c is negative 2. So our a is 1, our b is negative 1, and our c is negative 2. Okay? Right, so the next part, by sketching 2 suitable graphs, show that f of x is 0, it has 1 root. Now your f of x is now this thing. So for part B, you're trying to solve f of x equals 0. So you're trying to solve 0 is equal to x squared, add 1, take away 1 over x subtract 2. Now, you don't know how to draw that graph, but what you could do is if you added 1 over x subtract 2 to both sides of the equation, you'd get the following. So solving that equation is the same as solving that equation, you know that. But you can draw this graph. This can be a g of x graph, this can be a function, that can be an f of x graph. You can draw those graphs and you can prove that this would only have one solution because those graphs are easy to draw. This is simply a quadratic in x squared, but shifted up by 1, the plus 1 there, like that. And this is a 1 over x graph, but actually it's been shifted to the right by 2 places, so like that, 1 and 2, something like that. And you can clearly see that they cross at only 1 point. So you can say crosses at 1 point, and therefore you can say therefore 1 real root. Okay? And for part C, use that iterative formula. So the iterative formula is as follows. So for part C, they say use the iterative formula. Actually, let me just copy and paste this here. Let me just take a little photo of that. So take that there, and it asks you, by using a suitable starting value, find the answer to 3 significant figures. Okay, so there you go. So that's our iterative formula. Now looking at your graph, you can clearly see that the solution seems to be lying in, for an x is positive number. So why don't we start off with something like x is 2? That wouldn't be a bad way to start with x is 2. So what we do is we state that our x0 is equal to 2, and our x1 would therefore be 2 plus 1 over 2 squared add 1. Now, you can do the following with your calculator to make this easier. So what you can do is you can say to your calculator that 2 equals. Okay, so 2 is your first one. So 2 is now stored in the answer function. Then you could copy out this here, and you could say that the iterative formula is 2, add the following fraction 1 over, now whatever you got for the one before, which I'm going to call ants now, squared, add 1. It will remember that. So it's going to remember as answer 2 because you press 2 equals. So therefore the next answer is clearly going to be this here, which is 2.2. So x1 is going to equal 2.2. But the beauty of this method is you can just press equals again, and it tells you that x2 is equal to the following. So x2 is equal to 2.171. So x2 is equal to 2.171,123. Okay, and then you can press equals again, and you get x is 2.175. So x3 is going to be x 2.175. Now you're asked to give your answer. Let's look up here what you're asked to give your answer to. Correct to 3 significant figures. So let's keep doing it until we get 4 significant figures equal to each other. So press equals again, and you get 2.1745. So x4 is 2.1745, and do it again just to check. X is 2.1745. So x5 is going to be x is 2.17456, and one more time, just keep pressing it. 2.1745. x6 is 2.17455 again. Now, what's correct to 3 significant figures? Well, to 3 significant figures, we see that we've had 2.174, 2.17 and 2.17. So the answer seems to be x is equal to 2.17 to 3 significant figures. However, there's something really important you must do. Look at the question. It says, and justify your answer. For 5 marks, you're not going to get 5 marks as simple as that. So to justify your answer, what you've got to use is you've got to go slightly above this value here. You've got to consider x is equal to, this is 2.17 to 3 SF. And what you've got to do is you've got to go 2.175 a little bit up and 2.165 a little bit down, and you've got to work out f evaluated at this here, and you've got to work out f evaluated at this here. Back to your original function up here, and your original function was x squared add 1, okay, your f of x, take away, and it was a fraction 1 over x subtract 2. So x subtract 2. So that's your function there. And you're going to evaluate this, calculate this at 2.165, and you get yourself a negative answer. So you get yourself, you can type in here the answer negative 0.37. So negative 0.37. And if you go over here and you press calculate at 2.175 now, you get yourself 0.01, so it is 0.01. So therefore you can say, therefore, change in sign, okay, and as f is continuous. As the function is continuous, you must state therefore root between 2.165 and 2.175. Okay? And you're done then.